Hi, this is Mackenzie Banks. I'm just going to be going over the Chapter 21 video assignment, and this is what it's got. So the question ultimately is having us determine the age of a rock that was found to contain 5.51 milligrams of uranium-238 and 1.63 milligrams of lead-206. So for the first part of the equation, we have to figure out how much did the 1.63 milligrams of lead-206 weigh. So when it was uranium-238 is what we have to figure out. So 206 milligrams of lead is equal to 0.001 moles. So the 1.63 milligrams of lead is equal to 0.001 moles over 206 milligrams times 1.63 milligrams is equal to 7.913 times 10 to the negative 6 moles. So before decay, it was 7.913 times 10 to the negative 6 moles uranium. And then the mass of 0.001 moles of uranium, 238 weighs 238 milligrams. 7.913 times 10 to the negative 6 moles of uranium is equal to 238 milligrams over 0.001 mole times 7.913 times 10 to the negative 6 moles equals 1.88 milligrams of uranium. So when lead was uranium, it weighed 1.88 milligrams. The second part of the equation, we are trying to figure out what was the total mass of uranium-238 originally. So in order to do that, we know the mass of uranium is now 5.51 milligrams. It was 1.88 milligrams when uranium lead used to be uranium. So the total mass of uranium initially was 5.51 plus 1.88, which is equal to 7.39 milligrams of uranium initially. For the third part, we had to figure out, given the half-life, what is the nuclear decay? So the half-life equation is 0.693 over K. So in order to find K, we're going to do 0.693 over the half-life of uranium, which is 4.5 times 10 to the 9th, which is equal to 1.54 times 10 to the negative 10 per year. So then, how old is the dang old rock? So this is a first order equation. So it's going to be time is equal to 1 over K times the ln of initial over the certain time period. And so time is equal to 1 over 1.54 times 10 to the negative 10 per year times the ln of 7.39 milligrams over 5.51 milligrams. This is all equal to this giant number, which is 6,493,506,494 times 0.29356 is equal to 1.9 times 10 to the 9th years. So the rock is 1.9 times 10 to the 9th power years old. But yeah, that is how we were able to figure out how old the dang old rock was. Thanks for listening. Bye.